looking. All right, this says radical 2x squared minus 3 pi x. Is that a polynomial?
Yes.
Yes. What makes it a polynomial?
There's two sides and it's being
Separated.
by subtraction.
Okay, separated with subtraction. Got it. And we got, so two terms. What makes something a polynomial? Like really, really?
Multiple numbers. Positive.
So close. Positive, whole number,
With
exponents. Yes, on x. So these are powers of x that have nice whole number values for those powers. So that makes this a polynomial. Now, radical 2 is a totally crazy irrational number, and that's fine. And so is pi. That's also fine. It doesn't matter. And you even saw some with fractions. Oh, 3 over 3. That's a silly fraction. How about 3 over 2? Those are just numbers. Numbers in front, coefficients, those are fine. It doesn't matter. What about 2/3 x to the 2/3 minus x to the negative 1? Is that a polynomial? No, why not?
Because both of the exponents are
Exponents, although crazy, too crazy. Those exponents are totally crazy. Okay, we want whole number exponents. What are the whole numbers?
0, 1, 2, 3 and above.
0, 1, 2, 3. How do you know that? How do you remember that?
There's a 0 and a 1.
Because there's a 0 and a 1. 0, 1, 2, 3, etc., etc. To help us remember that the whole numbers have a 0 and a 1. Okay. Very good. So today we are multiplying a polynomial by a monomial. What is a monomial? One term, single term. What is a polynomial? Many terms, multiple terms. Very, very good. So here we go. Let's do some algebra tiles here. Recall our algebra tile work. I'm too lazy to get out the algebra tiles for one thing, so we're going to draw them. What is the big square?
X.
Represents x being squared. And this sticky thingy is the unknown. And the cube?
1.
It's not a cube. It's a unit. Okay, it's a 1. Okay. And so we want to draw the following. We have 2 times the quantity x squared plus 2x plus 3. And what I need you to remember is that multiplication is simply repeated addition. And so if I have 2 of these polynomials, then we could simply write it out 2 times and add them, because that's all that multiplying is. It is repeated addition. And so x squared, we have 1x squared. What should I do for 2 x's?
2 1s and an
Wait. Say again? Two long sticky thingies. Yes, okay. 2 x's, okay, and then 3 units. 1, 2, 3. And, that just gets repeated, doesn't it? So 2 long x's, 2 unknowns, x's, and then, again, 3 little units, okay? And then we would combine these. We did that yesterday. And what do we get when we combine these algebra tiles? 2 of those x's squared and plus 4 x's, and then plus 6 units. Very good. And it turns out that, yes, we could write everything out if we wanted to and expand it and make it this big complicated thing. Or what property could we utilize? The distributive property, sure. And so we could just distribute. 2 times x squared gives me 2x's squared. And 2 times 2x's gives me 4x's. And 2 times 3 gives me 6. So we are just utilizing the distributive property today, which we've done a lot of. And you've already learned it. So how about that? Example 1. Use the distributive property to write an equivalent expression. Use the distributive property to write an equivalent expression. I like the language that they use in these directions. They say to write an equivalent expression. Are we solving for anything? No, we are not. We are not solving at all. And that's really important. I think the biggest problem in algebra is when students use the word solve for everything. We aren't solving. We are simply transforming something. We are making something similar looking, representing it in a different way. And that's most of math, rearranging. So we have an 8 that we're going to distribute here. 8 times the quantity 6g minus 5h plus 8. What do we get when we distribute the 8 to the 6g? 48. 6 times 8 is 48 g's. And 8 times negative 5h? Negative 40 h's. And 8 times 8? Do you know the number one reason students fail algebra? They don't know their times tables. That is the only reason you would not do well in this class. If you don't, and I'm saying this now because in the next section, the next unit, we're going to get into some stuff where you have to know your multiplication facts cold. And if you don't, it's a big problem, okay? You have calculators, but boy, it makes it take too long. So maybe have to throw in some mental math in the delta math to get us, refresh our brains on all those multiplication facts. All right, what is 2 times the quantity 7x squared minus 2? What do you get? 14x squared and then minus 4.
You know that it's not plus 8.
It's not plus 8. Thanks. What should it be? Ah, and now you're really going to wonder if I did that on purpose or not. Uh-huh. All right. Negative 6 times the quantity 3x minus 5x squared. What do you get? 12.
Negative 12.
Negative what?
Oh,
what was I just saying about multiplication facts? Okay. 6 times 3x is 18. 6 times 3 is 18. So negative 18x. Negative 6 times negative 5x squared. Positive. Yeah, ladies and gentlemen, negative times negative is positive 30x squared. Okay. Do you have any questions on those? These are super easy. We've done these for like 6 months now. Yep. Yeah? Okay.
Another one?
Yeah. Example 2. Use the area model to write an equivalent expression. Really, this just came about because the Delta Math didn't have some awesome choices for us today. So the problems weren't exactly what I was hoping for. Use the area model to write an equivalent expression, but I do love the area model, and we will do a ton more area models. So I wanted to refresh your memory here. So we're going to use an area model. So we do want to draw what this could look like, because when we multiply, we are just finding the area of some rectangular shape. And so if I have negative 5 times 6w minus 4.8, one thing that we can do is I'm going to put a negative 5 on one side, the width in this case, and then I can write 6w minus 4.8 along the top of our rectangle and separate them we did this before with just the very first week of school, right? We did the area model. Do you remember that? And I showed you that. So just to refresh your brain here, we could take 48 times 22, and we could write an area model and do the math pretty quickly, because 48 was really 40 plus 8,
Yeah.
and 22 we could rewrite as 20 plus 2, and those typically are pretty easy. And then we could fill in the partial products, right? So 40 times 20 is 800. 800. Okay. And then 40 times 2 was 80. And 20 times 8 is 160. And 2 times 8 is 16. And so if you add up all the parts, you would get the full product. You remember that, yeah? Okay, good. So now we're doing the same thing with variables. And so again, now we're multiplying -5 times 6w. What do we get? -30w. And what do we, -5 times -4.8? Positive 24. How do you know that? I use my calculator, yeah. That's what I hope you say. Okay. Yeah, it's true. So this doesn't clean up at all. The answer is just -30w and a positive 24. And so that is our equivalent expression. All right, over here, this is the one that really matters. 5x. Oh, that's an x. And then on my top here, I'm going to write my 3x and my positive 7. And so we can split that up. For all the money in the world, ladies and gentlemen, what is 5x times 3x?
15x to the second.
15x to the second, x squared.
I have all the money.
Because you got all the money in the world. Yeah, sorry, I don't have it. What are you gonna do? X times x is an x squared shape, a square shape. That's right. So x times x, we get x squared. What is 5x times 7? 35 x's. Very good. So our equivalent expression is
15x
squared
30.
plus 35x. Very good. 15x squared plus 35x. All right. That's good enough. Do you have any questions? This is the silliest lesson ever. Okay. All right. Go do some delta math.